Quest Object Views C++ demo. Just want to start this out with some basic assumptions that Quest has and some of the product goals for this product. Quest started out as a traditional X and intrinsic-based software company that is an OSF member, that does the Motif toolkits, does OpenLook intrinsics, and also has builder technology for intrinsics. About 3 years ago, we internally realized that intrinsics have their limitations, that when you get 200 or 200 widgets, you start running out of memory, and basically the system starts to bog down. No matter how well we did shared libraries, colas, and data structures, we tried to fit them on a single VM page, which was really a major portion of our Motif business, that still didn't help you. So we looked for we on a quest for some technology, and we looked at all the different technology out there. We found only one real C++ technology that really made sense, and that was a research project out of Stanford University called Stanford Interviews. And this is a research project that was done by several PhD students and a professor at Stanford. And they basically did both the structured graphics and the interactive graphics. The API was quite clean, and it was basically a very primitive set of interactive objects. So Quest started the project approximately 3 years ago, and this is what you see here today. Quest has been shipping object views for over a year now. This is a brand new release, which will be shipping in about 60 days. And this release here, we have full keyboard traversal, full mnemonics, tab groups, and all the things that Motif does as far as the keyboard. And this is Motif 1.1 compliant. We are working on 1.2, meaning tear-off menus, drag and drop, internationalization, etc. Since we are OSF members, we get pre-release snapshots of Motif, and we also have a good working relationship with AT&T since they OEM all their OpenLook intrinsic requests. So we get pre-releases and they get cooperation in getting the OpenLook information. So this allows us to basically keep up with the current GUI trends in the intrinsic world. So the basic premise here with this product is this is a leapfrog technology. This leapfrogs intrinsics. The assumption here is that intrinsics and C are really obsolete, and if you're starting a new project, why not start with a C++ class library instead of using intrinsics? So here's the periodic table of object views interactors, and we're going to show pull-down menus and some pull-right functionality. Here we have arrow buttons. We have the double height button, toggle button, an option menu, Motif scale, of course the Motif radio boxes, text editor. Now here you have the Motif compliant file selection box. Everything was re-implemented in C++. Here's the scroll bar. Scroll list, pop-up menu, draw button, and a fully functional pane window. This is just a sample. This is equivalent to the Motif periodic for those that are familiar with that. Now the exact same binary was started with a -OpenLook flag. Let me exit here. This Windows will start at 2D. Start this over. Okay, that's right. We have a 2D implementation and a 3D implementation. That was started with the 2D implementation. So here's the 3D implementation of OpenLook. And here you have basically start with the pull down. You have stick pins. So stick pins we give you automatically on menus. You have the arrow button and the double height button. Here you have the checkbox. Option menu, scale, radio box, text editor. Now here's the interesting thing. This is a file selection box, and some people say, well, that's really a motif widget. This is actually a composite file selection box object that is fully open and compliant. So this is actually legal, and this is fully functional, just like a motif file selection box. We have the scroll bar, scroll list, pop-up, which even gives you a stick pin, draw button, ultimate pane window. That's just a real quick overview or the executive summary of the library capabilities. Now everybody understands that in graphical user interface environments today you need a builder. So Quest has object build that ships with the object use environment for developers. Now here you have the tool palette, which has primitives, dialogues, menus, scenes, and then down below you have your custom objects. So we set the foreground and background. You can actually change that. You have full color selector here, full RGB control, and hue, saturation, intensity. So that's the background that should be changed. I'm going to go to the foreground. Because I don't like to do it that way. That's a little hard. Here you can get the full RGB database up. So you can just select very quickly. Then you have it. So this is another way to select if you want to just actually pick a name. So you have full background color, foreground color, you have the RGB, you have hue, saturation, intensity, and you have intensity values here. Of course, you have full access to dialogues and other composite interactors. You also go into the font selector, and you have full access to all next level fonts. Okay, so I'm going to start fresh now. I just showed you a real overview of some of the interactive objects that are available. We're going to open actually the color selector, the code for the color selector. In other words, Object Build was built with itself. We do use our own products to build the builder. So we're bringing up the color selector. This has all the member functions. Those of you that are used to Intrinsic are used to callbacks. And what we have in the C++ world and the object-oriented world is our member functions. So we're going to go in here and do an examine. Hit a push button. Give the class name, the member name, whether or not to export that, button state name, setting value. Window button state, and the official values, etc. Now this is a real primitive editor. Most builder editors are primitive, meaning that they're not very usable. And most developers want to go outside of that builder and use an Epic or an Emacs or beyond. Property sheet that allows you to configure an editor of your choice. This one is using Epic, so I hit the edit button. It executes Epic and comes that callback right in there. So now you have a real editor that you can, feel comfortable with and use to do the member function. In addition, it keeps the member function a separate file instead of embedding that in your UV code or giving you templates, so you don't have to override it when you're changing your interface. It stays there. You can actually go outside of the builder and edit it with an editor, save it, and it will come into the builder correctly. So by keeping it a separate file and keeping it modular like this gives you a lot of flexibility. Those that want to create new tools, they actually hit the create button here, let's say we wanted to make this color selector an actual tool and save all the member function capability, you could actually hit the create button, name it, and it would be added to the custom part of the menu with all the colors, all the values, and all the member functions in there as a custom tool. Now, another interesting thing is that all these tools here are installable or uninstallable. You can actually remove them and install your own tools that are for your particular corporate style guidelines. So if you have corporate style guidelines, this allows you to enforce that. Okay, well, we actually will have a Q&A session at the end of this, but to answer that question, this right now is being ported to all major workstation platforms. We also are working on a Windows port, so we'll have portability with Genomics, Windows NT, Windows 3.1 platforms. The X market is changing. So again, that's another reason why developing intrinsics may not be a smart decision today, because Windows NT and some other Windows environments are going to be coming.
May I have your attention, please? Now, we have a winner of the Apple PowerBook 140 from the Apple Booth 717. The winner of the PowerBook is Eric Lindbergh of Technicron. That's Eric Lindbergh of Technicron.
C++.
Congratulations, Eric.
2.0 C-front compatible. So any AT&T 2.0 C-front or greater will work. It will also generate an interface file. You can also execute. From the edit, you can do undo, redo, cut, copy, paste, all the standard things as far as showing glue and hiding glue. Composition. Now in the intrinsic world, these are called manager widgets. In the object views world, we have composition interactors. And you have things like HBox, VBox, pane window, effect trays, etc. You have ways to align and multiple view. Now this is a very powerful feature that's not really in other builders. It allows you to get multiple views of the same exact application, and basically if you're editing the member functions, you save it, it'll save those member functions. So this is the same view, or a different view of the exact same environment that you're building. It's actually starting up another object build. You can have multiple object builds. If you want to have 3 or 4, then you can be working on different parts of the interface simultaneously or have different views. So we have a panner object here. You can pan around, and you can also magnify. So you can, if you want to do fine detail control, you can magnify this, you can enlarge it, and you can do the things that you need to do in the different view. And they are tied together. So that's a very rapid overview of the builder. This currently handles interactors, and we will be moving to glyph support once glyphs stabilize from Stanford. And the interesting thing about glyphs is those will actually give you up to 100 times better memory consumption than intrinsics will. So some of the benchmarks we've done is it's